So my one good thing today, I got to go to daily mass. So that was a good thing today. I needed that. Anybody else want to share their good thing for today?
I've been awake since yesterday, 11 a.m. So I'm happy I made it to Zoom.
We're glad you're here. Yay. Anybody else have something? One good thing.
I'm happy to be home from school and with my family.
Yay for you. Cole, any good things today you want to share?
It's nice outside.
Sometimes that's what, you know, we have to be grateful for the simple things. That is it is gorgeous outside. We should all be zooming from outside. It looks like I'm zooming from San Francisco, but I'm really not. Okay, so here we are. We have a whole mess of things. So does everybody have their course pack pages ready to go? If not, you can follow along or print them from, that's why I try to send them early. So until people get their course pack pages. Does everybody here have their course pack though? I know Cole does. I think Lakeisha, you do, because we talked that day you were in the bookstore. Madeline, do you have yours? Okay, so then we're just going to move on. So here they are. If you are watching the video, I know I keep saying this in the email. It's going to sound like I'm a nagging mother, but I am a mom and I am nagging just for 2 seconds. Please work on these worksheets while you're watching the video. If you just watch the video, you may as well just turn the video off and go watch a show on TV, because just watching the video and not engaging in the worksheet is not going to benefit you, not like being in a live class. And so if you're watching the video, it is, I assume that you're going to be working on the worksheet at the same time. So I'd like us to start with 3.1. I'm very ambitious today. Does everybody see on my list here? And that's because I'm trying to touch base on some things that I didn't get to see all your sweet faces last Thursday for the 3.1, 3.2, and 3.3. And I want to make sure that, and if we cover, so if did anybody watch that video from last week that I just put out there for you guys in case anybody wanted to work on those worksheets?
Which video again?
It was a link in JetNet that I put. So if anybody did, if I start to do a problem that you already watched on there, then tell me and I won't do it, because everybody can go back and watch that video. I just can't remember what was on there. So I would like to start right here with 3.1, worksheet number 2, page 437, problem number 2. It gets us to one of the big topics for chapter 3, and that is, how do we decide what the best measure of center is? As far as using a histogram and choosing where the mean and the median would be. Okay, so if we look here at problem number 2, this first one on the left, histogram A, can anybody tell me, what do you think the shape of this histogram is?
Right.
It is a skewed right. Excellent. And so, and these aren't, when I ask questions, it's not like to test you. It's just to see if, like, so we can all go, oh, yep, I'm kind of getting this or I'm not getting that. So when Lakeisha said it's skewed right, what do we automatically know about how the mean and the median are related? What does that tell us? What did we learn? If you don't have your course pack out, you should probably have that out and open. I'm getting mine too, like I don't have it memorized. So knowing that it's skewed right.
I should know this because I've been doing math since like 4 a.m.
Anybody know? I'm going to give you a hint. I'm going to challenge you. It's about page 79. We did some discussing in the course pack.
Mean is greater than median.
Excellent. It's actually page 78, wasn't it, Madeline?
Yeah.
So, and I bring things up in the course pack because my goal as an instructor is to teach you how to be super resourceful as a student. That is, being born smart, I don't think has as much to do with being successful in any class in school as it does as your how to be a really strategic student, okay, and your effort. And so that's why I always want to point out where you can find things in your course pack, because when I'm not around, which is 22 hours of the day that we see each other and 24 hours on the other day, right? you're gonna have to rely on your first pick. So right here it is. If it's skewed right, this bottom one, we know that the mean is greater than the median. Okay, so we know that it's this, right? So we're gonna choose all the ones where the mean is greater than the median. So that would be 2 is a possibility and 6 is a possibility. I'm sorry, 2 and 4. I do know my. Okay, so of these two, does anybody have an idea which one we should choose as the set for the mean and median? 4.5 and 4.1 or 6.1 and 5.7?
I know it's something about the 50% on the left, 50% on the right.
You are right. So the median tells us that half of the data should be below that value, right? And half of the data should be above. And this relative frequency means that it's basically, these are percentages. So this point, it's just a little bit above 0.4, we'll call this 0.43, which means that 43% of this data set is in this first category, right? Would you all agree it's probably maybe 0.43 or 0.42, whatever.
Yeah.
So that means the 50th percent, right? The part that's 50% has to be in this category. Kind of like playing a card game where you're like, I know these cards are gone and I know this card is still left, right? So I know that
So it's
50th.
option 2.
So yep, so I would say it's 2. This is the one. Okay, so using a similar strategy, I'm going to let you all walk through the second one.
One or 4.
So, and why did you choose 1 or 4?
That looks like a uniform histogram to me, and so they should be about equal.
Okay. I agree on the equal. What do
Or
we,
maybe I used the wrong term.
that's okay. That's why I want to throw it out there. So this one would be uniform, but Cole, you're on the right track. Can anybody help Cole out? What is it called when he said that they should be about equal?
Symmetric.
Yep, great job.
Metric.
Yes, teamwork, teamwork. So this one is about symmetric. And now remember, data is never perfect, right? And so when we say about, it's approximate. And so would you all agree that 1, and what was the other one, Cole? 4?
4.
Okay. Would you all agree that 1 and 4 are probably the 2 choices that we're going to make?
Yeah.
Okay. So which one do you think is,
1.
and why is that?
It just seems like half the data is on both sides of those numbers.
This one's easier to tell because it's
right in the center, I guess, of a symmetric.
yeah. Oh geez, Sarah. Yeah. That when they're symmetric is a little bit easier to tell where they should be because it should be in the center. So great job. So that's kind of the big overarching thing in unit 3, in chapter 3. So when we talk about it being skewed right, which, just for the folks at home, which of the mean or the median should we be using as our measure of center when it's skewed? Back to page 78.
Median.
There you go. So the median. So we would use the median here. And on the picture where it's symmetric, which one would we use as the measure of center?
The mean.
The mean. Okay, excellent. Okay. So next up, I would like to go to 3.2 worksheet number 3. Speaking of gas prices, woo-wee, they're definitely higher than $2.79, aren't they? I haven't bought them in a couple days, but with the pipeline thing that happened last week? Has anybody bought gas lately?
$3.
3? I guess I was thinking it would be even higher, but that's definitely higher than 279. So this is a great topic. I'm glad that this brought up, because in the chapter 2, project 1, I asked you to pick a couple of qualitative variables and a quantitative variable. And I want to make sure that we're really hitting home on the difference between a qualitative variable and the quantitative. And I'm bringing this up not just for my precious 4 people right here in live, but for my folks at home as well. A qualitative variable is something that's not numerical. So gas prices would not be qualitative, they would be quantitative, because there's something measured, right? Or counted. That would be a quantitative variable. So thinking about that, and if you did not get the feedback from your chapter 2 project 1, you should go back and look at that. Wanted to bring that up. It says, what is the unit of measurement for gas price? What did they tell us that how are they measuring gas price?
Price per gallon. or
US
dollar.
dollars per gallon.
Yep, US dollars per gallon. Excellent. And it says find the mean price for 2010 and 2017. Well, fabulous. Let's go to Statcrunch. Where is my mouse? There it is. Okay, so we are working on 3.2 worksheet number 3 on page 442. We've got the gas prices from various countries. They told us it's a sample, so that's something we're going to need to know, right? That's important. It's a sample, not a population. And for my folks at home on the recording, just a reminder too, some folks asked about the data set that I had you take for the survey. I haven't added that all in. So when you look at our class survey data that's available in our class, it's from the winter semester. So don't stress that it's not all been uploaded with everybody's info yet, because our class is so small this summer. I wanted to make sure we had a really good data set to work from. So this is 2 sets, 2010, 2017 gas prices here. And this is a great time for us to remind ourselves, how do we find the mean? So summary statistics. So in Statcrunch, we're going to go to stat and summary stats and go to columns. And we could have renamed the columns, but we're going to choose var1 first. And I'm going to just choose everything that's already there over here on the right-hand side. And right now we really just need some basic things from there. And because if you look at part D, it says, are the values found shown above parameters or statistics? This is going to tell us what kind of standard deviation we need to have. So when we find the mean in part C, which we're going to find here, are these statistics or parameters?
Statistics,
And how do we know they're statistics?
because statistics and samples go together.
Okay, excellent. So that's why I brought up, it's important to recognize that this is from sample data, because then we know that the summary characteristics are statistics. So that also tells us that here in Statcrunch, we are going to just get the regular old standard deviation that comes out of this. See, it says standard deviation. If it was a population, we'd have to go over here in this box and choose unadjusted, but we don't want that one anyway. So we're just going to hit compute as is. And voila, can everybody see the summary statistics that came up? So for the 2010, the mean is 5.34. And actually, you know what I'm going to do? I'm going to just name this 2010 and 2017 there. Just be done with it. Okay. So I'm going to go back to stat and summary statistics and columns, and I'm going to choose, see if I can do them both. Oh, we can do them both. Yay, even better. Okay, so there they are. I renamed them so everybody can see 2010, 2017. And so the average gas price in 2010 was $5.34, and the average in all of these countries in terms of dollars were $4.20. Then in part E, it says find the standard deviation for both years. And they gave us those in 3 decimal places. So we would have 2.095, and we're going to have to do some, oh no, 1.098. It says which year had more variability in gas prices? What do y'all think? Which year had
2010,
2010? And how can you tell?
the standard deviation from the mean is higher.
Yep, the standard deviation is higher. Excellent. Okay, so part G says interpret the mean and standard deviation for 2017 measurements. Interpretation is on the yellow sheet. It's also at the end of 3.3. Actually not the end, but on page 86 for interpreting the mean and standard deviation.
Is that the give or take that you said we would be marked incorrect for if we did not specify give or take?
You're on top of it, girl. Yes, it's calling me out. I love it. So here on the yellow sheet, I really recommend if you haven't pulled them all out and stapled them together that you do, because these are just going to be like your lifeline for the semester. And the more, it's kind of like, does anybody play a sport like tennis where you have like a particular racket that's for you, or like golf clubs, right? It's like Tiger Woods practicing with his own clubs, and then he shows up in Ireland and he's like, yeah, I'm gonna go golf on this course, and he plays with some new clubs and he expects to be really good. That's kind of silly, right? Because he hasn't even practiced with those clubs. So the more that you practice with this yellow sheet, you're going to be very confident about using it because you're going to get familiar with it. So right here, oh, this is the one, right, that it doesn't have it on here. Oh no, but right here it is. We added it. I keep forgetting from last spring. Interpretation, on average if. So that's where we are. So on average. Oh, we're not talking about slope. I'm so right. This is the one where they don't have it on here. So I would add it to your note sheet for the midterm, because this is super important. I mentioned it in the YouTube videos. But it's right here. We expect. I just made a tape for chapter 4.1 the other day, so that's why that was on my brain for the slope. So this is page 86 in the notes for chapter 3. I know I marked all this. This is super important for you to have on your note sheet, but right here we expect. You're right on the give or take. Thanks, Lakeisha. So we expect gas prices in 2017 to be, and notice that the gas prices in 2017, that's our story. That's the context that we're talking about. So we expect gas prices in 2017 to be, and we're going back to the mean for 2017, so $4.20. And then that's where we have the comma, give or take the standard deviation from 2017, which rounded in pennies, right, would really be $1.10. So Lakeisha was correct. On the chapter 3 review worksheet, if you tell me the mean is this and the standard deviation is that, it's going to be counted wrong, because you would never go to your boss and say that, right? You would give it in the context of whatever you're speaking of or writing of. How's everybody doing so far? Give me a thumbs up. Is everybody okay? Madeline, you're okay? Lakeisha, you're okay? Cool. Okay.
With the standard deviation for 2010, I can't remember. With 5, do you always just round that up? So would that be $2 and, or I'm sorry. No, yes, we'd round it up, $2.10. Never
Mhm.
mind.
Yeah, both of them. And so it's
Yep.
weird because in part E, it says give 3 decimal places, but because this is money, we would naturally just use 2. So you're
Yeah.
right. Yeah, good question. Good question. And if you are not a professional rounder, you will be after this class because my stat lab is so picky. If you haven't already noticed. Okay, find the variances of the gas prices for 2017 and 2010, showing work. So variance, right, is the square of the standard deviation. So we have to take, so for 2010 and 2017, we are going to find, and these are sample variances, so we're using S squared, right? So I'm going to use all 3 digits on both. If you used 110 and 210 and squared that, that's just fine as well. So depending on if you use the rounded value to start or not, I came up with 4.389 and 1.206, something thereabouts. Everybody see that okay?
Yeah.
Okay. So variance is found by taking your standard deviation and squaring it. Excellent. Okay. So then one of the next topics that we worked on in chapter 3 was given a scenario and telling you that the scenario is normally distributed, that we can use the empirical rule, we can then create this bell-shaped curve, right? And we kind of know where percentages of the data should lie. So it says in a large sample of customer accounts, consumers' energy determined that the average number of days between when a bill was sent out and when the payment was made is 32 days with a variance of 49 days squared because the units are squared, right? Assume the data to be approximately bell-shaped. Okay, so that allows us to fill out this curve. Compute the standard deviation of days for a bill to be paid. So I'm just going to remind everyone that standard deviation is the square root of the variance. So our standard deviation is the sample. Yep. So you said square root of what?
49,
Is
7.
excellent. So I'm going to pause the recording and I'm going to let everyone at home and live use their yellow sheet to help them with the guide of this curve. I'll let you take a moment and fill these in. I don't get too picky about where you draw your lines. Just make sure that your numbers are filled in correctly with the percentages. So using the mean of the X bar of 32 days and the standard deviation of 7, I'm going to let you take a minute or two here, well, a couple minutes, and fill this in and see where we can get with answering C through F. And you're all welcome to help each other. I'm just going to pause the, I'll pause the recording. So I'm going to start filling it in and then we'll see if everybody's in agreement. Everybody in agreement so far?
Yep.
Do you not know the latest stuff? Oh, yeah, that, I'm saying a nice sticky because I'm gonna see today, no matter what.
Okay,
Mom's favorite.
and I always like to just mark for myself before they even ask me any questions, where are those unusual values? So they're always anything past 2 standard deviations, right? Below the mean, and anything past
Oh, yeah.
2 standard deviations above the mean. This is one of those really important fundamental things to learn so that at the end of the semester, we're actually going to change this up a little bit. We're going to get more critical as far as, are we going to allow 2 standard deviations, or are we only going to allow 1 standard deviation? Or are we going to allow 2.5? And so I think it's good to kind of bring up the big picture so you can kind of be mulling it over for a while. And since you only have 5 more weeks to mull it over. So let's say this, my plastic cup here that I had my water in, see that? If you ever notice, like on the bottom of like any plastic cups, there's thing, it's called a gate. I made plastic parts in college. This is where it comes out of the mold, and that's where it breaks off from the mold. And sometimes you ever felt that on other plastic things, you felt like a little scratchy thing. It's like, that's where the mold got cut off. And sometimes it's real smooth and sometimes it's not. And they measure that. Now, do you think that if when they measured this, if they were like, oh my gosh, this needs to be thrown out because I can really feel the scratchy, the gate. The tolerance was probably pretty big, right? It's probably like, nah, not a reason to throw out the cup. Now, if I were talking about something to do with, I don't have a conversation. I can't have a conversation when you guys are itty bitty. But if I were talking about something with maybe a cancer drug trial that I was doing, I might have to be more critical about how far out I can let something be before it becomes unusual, right? Or if we're talking about the instances with the coronavirus vaccine and people getting the virus even after they've had the vaccine, or like some of the what do they call it when you exhibit the symptoms after you've had the vaccine? The what?
Side effects.
Yeah, side effects, right? So they have to decide, like, is this unusual that these number of people have had a side effect or not, right? And so that's where, for the first half of the semester, we're just going to use 2. 2 is going to be our thing. But then later on, depending on what we're talking about, something we don't care about, my class, right? Or something we do care about, a human, we're going to decide how our tolerance is going to be before we say something's unusual. Okay, so that's kind of the big picture I want you to try to start taking on. So let's go back to this and finish it up.
Oh, yeah.
So our days between when a bill was sent out and when the payment was made, on average, people wait 32 days. Roughly 68% of all customer accounts are paid between what time frames?
25 and 39 days.
Okay, right here, 25 to 39. Excellent.
Yeah, the tail blues, those planet.
About D.
49.85%.
Okay, you're good. You made sure that you didn't include this 0.15, right? Because that's just past.
Okay.
Excellent. So what was it again? 48.
49.85.
Yeah, 49.85. Thank you. Good job. And what about E?
97.5%.
Everybody agree with that? 97.5 is less. Okay, and what about F?
Yes, because it's 2 standard deviations from the average.
Okay. Excellent, excellent. How's everybody feeling so far? Chapter 3. Are we doing okay? Getting the big picture. This is if it's bell shaped, we can do that. Okay, that being said, I'm skipping the next page. I actually. I'm gonna look at something here. Okay. I want to make sure I'm getting everything. Everything is so exciting. Let's do some group data. Group data becomes a big deal throughout the whole semester in a couple of different facets. So the worksheet 3.3, worksheet number 2. I'm kind of skipping around here to make sure we hit on lots of good things. So let's look at number 2 and then we'll go to number 3. They're both group data, but just in 2 different ways. So this table here, we asked a group of people, how many movies did they see last month? The table shows the results. So it says there were 4 people that said they didn't watch any movies. There were 12 people that said they watched 4 movies. Okay, so how this data could have been written out is there could have been like this, right? Representing those 4 people. And then there were 3 people that said they watched 1 movie. Does everybody see that? So the data could have been listed out like that. But that gets kind of tedious. So putting it in this form allows us to look at the big picture and just go, oh, these are the number of movies that people have seen. Nobody saw more than 5 movies, right? And these are the number of people that saw each of these number of movies. And so that's why we call it grouped data. So it says, how many people took the survey? So we need to add up all of the number of people that took the survey. So we have 17, 24, 36, I think it's 39. Is that right?
Yeah.
Okay. And then it says calculate the total number of movies seen in a month by all the survey takers. Well, that means we would actually have to multiply these 2 columns together. But what I'd like us to do is go to Statcrunch, because Statcrunch is going to give that to us. So if we did this by hand, we would say that 4 people had 0 movies. So they watched a total of 0 movies together, right? And then these 3 people all each watched 1. So they watched a total of 3 movies together. The next group, these people watched a total of 20 movies together because there were 10 people and they each watched 2, right? 21, 48. This group, these 12 people each watched 4. And then the last group of 3 people each watched 5, so 15. So if we add that up, I believe we get a total of 107 movies. Now it says calculate the average number of movies seen in a month per person surveyed. So this is what we call a weighted average because we're taking the total number of movies and dividing it by 39. And the total number of movies were basically weighted, right, by this category number of people. These would be the weights. And these would be the values. So we would take 107 and divide by 39 to get approximately 2.74. And what type of data is this? movies seen in a month. What we call this qualitative data, quantitative discrete, or quantitative continuous.
I know it's one of those quantitatives.
Okay, that's, yep. So it's one of the quantitatives.
Would it be continuous? Because it could keep going. You could see a million movies.
I like your thought there. It could keep going, but it's not continuous for that purpose.
Okay.
Anybody else want to choose?
Quantitative discrete.
You're right. And why is it quantitative discrete?
Is it because of the decimal figure? Is that why?
It's a whole number.
Okay, so it's a whole number. So I always ask myself, can I have half of a movie? Now, Mrs. Min can watch half of a movie because I always fall asleep in the middle. But let's pretend that you can only watch either a whole movie or not a whole movie, right? So we would say that it has to be quantitative discrete. And they only gave us whole choices, right? So we're going to say it's quantitative discrete. So if we talk about people or houses or cars or TVs or animals, they have to be whole, right? Anything that's measured, like gas prices, dollars and cents, length, weight, liquid, time, those are all going to be continuous because they're measured. They're all have decimal point values, right? So that's the difference there. You might want to, I would definitely be writing those down. Anytime you can think of it in a way that you're like, okay, it makes sense now, write it down. So you put it on your note sheet, because that is one to the very bitter end of the semester. We bring it up and students still kind of struggle with that towards the end of the semester. It's just a hard topic. So I'd like to do this one. I want to show you, because this was a nice one that we could do kind of by hand, and it made sense how we got the 107 movies, right? And then we divided by 39 to find the average number of movies. I'd like to show you how we would do the same one in Statcrunch so that you can kind of get the big picture of what Statcrunch does for us. I'm trying to get Statcrunch. Okay. So Statcrunch. This is 3.3, 2. Okay, we're just gonna do our own. New data table. Okay, can everybody see my Statcrunch screen okay?
Yeah.
So we're gonna put in number of movies and number of people. Okay, so I'll save this and you guys can grab it if you want to enter it too. It's good for you to learn how to do it on your own. I'm going to save this as worksheet 2 movie. Okay. And okay, I added it to the group. Okay, so we are going to go, when we have groups data, we're going to go to stat and calculators. And we're going to do a custom calculator whenever you have group data to find the weighted mean. So is everybody with me? Stat and calculators and custom. And then our values are going to be in the number of movies. Our weights are going to be in the number of people. And then we're going to hit compute. And so our average is that 2.74 and the standard deviation is 1.434. Yeah, 1.427 or 1.43. Any questions on that one? We're going to have an opportunity to do more with that here in just a moment. Okay. So, the next one I would like to do is on the next page. Okay. It is some grouped data, and this is good because you have some grouped data again in your chapter 3 worksheet, right? And I want to bring up the chapter 3 worksheet for a moment for a couple of reasons. One is we talked about this in the videos in chapter 4, so we haven't watched those yet, but we have data here, and then I gave you some summary statistics that that's what we're learning how to do, right, in Statcrunch as summary statistics. So I gave you the summary statistics that you need already on this problem. But what is up with these dots right here on the bottom of this data set for the chapter 3 review worksheet? Anybody have an idea? What might those dots mean?
Could it mean the table continues on? They just only have room for so much here?
Okay. How can I verify that with the summary statistics? What in my summary statistics tells me that there's more than just 5 countries worth of data?
You could calculate those based off the information you have right there, and then if they don't match up, it's for more than just that.
Okay.
The N, it tells you it's 101.
Oh, the N tells me there's 101 pieces of data in my data set. So yes, I'm only giving you the first 5, and that's what it says up here. So I just want to make sure. It seems like every semester students start sending me emails. I don't know how I'm supposed to, I don't have the data. Well, I'm just saying, here's the first 5 pieces, but I'm already giving you all the summary statistics that you need to be able to answer all the questions on this page and the next page. Okay, everything you need is right there, trust me. I brought up the chapter 3 worksheet for a minute because you'll notice the very last problem on this chapter 3 worksheet is also some grouped data. And you'll notice that they don't all go by the same width. So you're going to have to make sure that you kind of hand calculate each of those midpoints to get those correct. So it is a quirky one, but we're doing lots of practice, and we're going to do some more practice right here in this table. And so I say we get started on the midpoints, and then we'll take a break and let you all work a little bit, and then we'll kind of culminate this worksheet back together, and then we'll finish up lessons 3, 4, and 3.5. Everybody's good with that. So before we take our break here, let's just, this data we have here is drivers in fatal motor vehicle crashes by age. So just to pick one out here, let's pick out the first one. It says there were 4,278 people that died, because that's what fatal means, right? They died in a motor vehicle crash, and they were between the ages of 16 and 20 years old. So we don't know the exact ages of those 4,278 people, right? We just know that they fall in this group. But if we want to find a weighted mean, an average of all of this data, then we have to have a number to kind of like a designated hitter in baseball, right? We need to have a number that represents that group. And so that's by finding the midpoint. So refreshing our memory on the midpoint. The midpoint is always the lower class bound plus the next lower class bound
Divided by 2.
divided by 2. Yep. So the first one, so we're using all of these numbers right here. So the first one is going to be 16 plus 21 divided by 2. Is 37 divided by 2.
$18.5.
Is 18.5. Now, before we start calculating each of them, we can see if there is a pattern where the pattern does kind of agree with the rest of the group, then we can use the pattern. Except for this one goes by 5s, right? And then this one goes by 4. And then the rest go by 10. This is a nice quirky one as well. So we're going to have to hand calculate the next one. So that one's going to be 21 plus 25 divided by 2, which is 46 divided by 2, which is 23. And then because the pattern doesn't work yet, we're going to do the next one by hand. So 25 plus 35 divided by 2 is 60 divided by 2 is 30. And we should be able to use our pattern. So how about we take a little break, and when we come back, we will finish this together recording. So there's a question on the chapter 2 review worksheet regarding number 4 on the frequency polygon. And if everybody turns to page 68 and looks at the definition of a frequency polygon, it says a line graph that uses class midpoints on the horizontal axis. And so on the graph here at the bottom of page 65, you can see that we've got midpoints. The first and the last are the fake classes.
Yeah.
And then you've got the midpoints 35, 45, 55, and that's what we labeled up here in the table. So you're going to use those midpoints first to fill in the midpoints here, and you're going to do the same thing on the chapter 2 review worksheet. You're going to use the midpoints first, and then that will work you backwards on the classes. And the same and that's what we did here in the on the YouTube video in these notes. We filled in the midpoints, and they gave us the classes, but you can use the midpoints to work backwards because you can see the width is 10 in our course pack, and you can see the width is 10 on this example in the chapter 2 review worksheet as well.
Okay, so the data between the 2 points will be the classes, like from 5 to 15, it would be 0 to 176.
So the numbers up here are the frequencies.
Okay.
So you have to imagine that the class is between, this is really the lower class and the upper, right? And then this is the lower class and the upper, and then so this is the next lower class, the next lower class, the next lower class, the next lower class. And because we can see that the width is 10, we know that the lower class is just 5 below that 35. So we could, so if you went to 55, you know that its lower bound is 50. What we wrote in here, and then we know the width is 10, so that they all have to just be 10 apart, 40, 50, 60, 70, 80.
Okay.
So the same thing here is, you know, the midpoints from the graph, right? The bottom of the graph. And then you can see the width is 10. So you can work backwards to find your first lower class. And then you can use the width to find all your other lower classes. And then your upper class is just always just 0.9 or whatever below that.
Okay.
So what would our first midpoint be?
15.
Okay, and so what would its lower class be then?
So for F15, and then you go back 5, which is 10.
So this would be
10.
okay.
And then
Can you see my paper?
19.9.
Yep,
Or
so we're gonna go by tens, yep. So then this upper would be 19.9, yep. And then you should be able to fill the rest of them out similarly.
Now, how do we know when to do like a 19.9 or a 19? Because I don't know if it was something you did or if it was on my stat lab, but something required a whole number instead of a decimal. Like, how do we know when to do that?
Right. That's when, if the data is all discrete data, it's like houses or people, then you can't have 0.9. So that's
Okay.
why they just would do 40 or 39.
Okay.
But because it's an exam grade and you can do 0.9.
Mm-hmm. Oh, I don't know. I was struggling so hard with this. Okay, I get it. So then these numbers at the points are the frequency.
Mhm.
Okay. Okay. All right, I think I can manage the rest.
Okay. So I'm not sure if Cole's back from his break. Let's just touch base before we finish up the day. Let me on the project. So tonight we have the chapter 2 review worksheet that's due, and then the chapter 2 project, the second project that's due. And let me click on that.
I did have another question.
Okay, just one moment. Let me just check this out here. So for the second project due tonight, it is asking you to choose a data set. And it says find a publicly available data set in Statcrunch. And your data set needs to have at least one quantitative variable with a lot of numbers and variability. So kind of maybe like numbers that seem to kind of be all over the place. Let me know the data set you chose. Choose a quantitative variable from the data set and let me know what that variable is. Then you're going to make a histogram using the sliders in Statcrunch. So let me go to my Statcrunch screen here. Can you see my Statcrunch screen okay, Lakeisha?
Yeah.
So you go to applets and it's asking you to go to the histogram right here with sliders. And then it says, I got to select a data set first. Excuse me.
Okay.
Thank you. Whoops. I need to find data. So we're going to go to data sets. And we're going to click on one. And let's see. This movie set data. Taking forever. What was your other question so I can be prepared for that?
When you're doing like the midpoints and then you get to the end where it says over a certain number, do you leave that box blank or do you just
You,
put like
you-
the next, what the next one would be?
yep, just follow the pattern and put the next one.
Okay.
Yep. So for the project here, I'm gonna choose one that has lots of variability. So I'm gonna choose the budget maybe. Or I'm gonna use the worldwide gross. So it says go to the applets and choose histogram with slider, and I'm gonna choose the worldwide gross in millions. And hit compute. Okay. And then it says to the starting point in the histogram applet is blank for the frequency distribution. So mine is at 0, right? And I could make it negative if I wanted, but then it's asking you to change it. So by changing the starting point, make at least 2 histograms that have very different shapes. So if here's one that I could copy and paste, and then I could change it, and this one's hard to make it change shape much at all. This one doesn't change shape much. A little bit. I might be able to do this applet here with the budget. Let's see. So there, it looks like it's different, right? Then,
Yeah.
so you're just trying to make it change a little bit, and then get
Okay.
2 different discs. The idea is that everybody's just seeing the different shapes that you can have: skewed left, skewed right, symmetric. And then you're going to do the same thing with what happens if I change the bin width. See how my bins are getting bigger?
Yeah.
So,
Okay.
yeah, and skinnier, and can you get it to change the shape or not with that, and what does it do? So I want you to I'm basically wanting you to come up with comments on what does the starting point tell us.
Uh-huh.
And the bin width on the histogram applet is the blank for the frequency distribution. So what does that represent? If you were to put this in a frequency distribution, whoops, right? If I were to go and do like a frequency table, it's not going to do it on there. I don't have it right here. But if we were to do a frequency distribution, what does the starting the bin width actually represent on that? Hint, hint, it says the word width. And the same thing up here. What does the starting point represent if you were to make a frequency distribution? The
Okay.
starting point. So those kind of things, that's what that second project is all about, kind of investigating in Statcrunch.
Okay.
Yeah. Okay, and so you had another question, hon?
No, it was the one about ending the
Oh,
for the midpoints.
yeah.
Yeah, I didn't know how that applies if it's for like a whole bunch of numbers after the fact. I'm like, do you leave it blank or what? But okay.
Yeah. So so back to this worksheet here, the 3.3 worksheet number 2 with the fatal crashes. And if you're going to leave, go ahead, no worries. You go get some sleep. I'm just going to go ahead and fill this in as if people were here. Yay,
Okay.
Arshner's back. Yay.
All right, I will see you Thursday.
Okay, bye, dear. So
Bye.
Arshner, we're on page 448. If you want to join us, yay. So as we mentioned before the break, the first 2 groups were not, or the first actually 3 age groups were not all equally spaced as far as the width. So the first one was 5 away, 4 apart, and then it goes 10, 10, 10, 10, 10. So I found the first 3 by hand up here. And now that the rest are 10, I can now just use the pattern of 10 to fill in the rest. And then this one, I'm just gonna go with that. Okay. And it says here, be careful, classes is not consistent in this table. So it says, what is the total number of fatal crashes in 2017? So we could add them all up here. Right? And if we do that with our calculator, I believe we get 50,994 crashes. And that were fatal in 2017. That's a lot. Fatal means that somebody died. We can treat this population distribution as coming from a population, right? And that is because we have all crashes from 2017. It says, what is the modal class of the distribution? And so the modal class is, we're going to find where we have the highest frequency, which is the third class here. And they want us to give the class grouping, which would be ages 25 to 34. Did you find the page okay, hon? Yay! She's in business. Okay. Explain what the modal class means for auto insurance rates. So it means that that class is going to pay higher for their insurance rates, right? Because they have almost over double some of the other groups as far as the number of crashes. So they will pay higher rates. Find the approximate mean of the distribution, and then it's going to ask us for the approximate standard deviation and then the mean and standard deviation. So if we go to Statcrunch, I have the data already typed in for you all, so you can find it. Did it work the second time?
It just made me like, I'm just gonna reopen it.
Yep, I always, when I click on Statcrunch and it gives me that error, I click exit out of that little window and then I go back and click on Statcrunch website again, and then it's fine. I don't know why it does that every single time.
It's just, okay.
So I'm just gonna look and see if you're in my group. So for those that are on the recording right now, I'm recording. If you're not in my group, I'm going to point to how you can get to my stat group. It says there's only 11 members, so that tells me that not everybody's part of it yet. Members. So Arshnor, you are going to need to do that. So under settings, you're going to copy the group link. I'm going to put it in the chat right now.
Okay.
Actually, I'm just going to email it out because I have a feeling there's others that don't have it either.
So I clicked on Statcrunch and it's saying, view the data sets from your textbook.
Nope, you want to be part of my group. So you can't get to this until you're part of my group. I'm going to send it.
And then these, do we turn these in too?
Nope. So the only thing that you turn in is in JetNet. Everything, all my assignments are right there. It'll say what's due. So you'll just look ahead, like tonight, the chapter 2 review worksheet. And I can tell you what pages you can pull those out right now while I'm sending this email. Page 428.
So I take a picture and then upload that on JetNet.
Yep, you take you use the scanning app that I have in the scavenger hunt.
I
So-
downloaded that.
Yep, so the chapter 2 review worksheet is, this one's really long. It's page 428 through 433. That's what's due tonight at midnight. So here we are, we're in Statcrunch and it says 3.3 worksheet number 2. Worksheet 2, it's problem number 3, fatal crashes. So here we are, midpoints and frequencies. And it's what we put on in our table. Can you see that, Arshnor, just so I know what I'm sharing?
Yes, I also have it pulled up on my end.
Excellent. Okay. So to do a weighted mean, which is what we did in section 3.3, whenever you have midpoints in class data, you have to use this weighted mean idea here in Statcrunch. So you're gonna go to, everybody wanna write this down, all my folks at home on the recording, you're gonna go to Stat, and you're gonna go to Calculators. And then you're choosing the one at the very bottom that says Custom. So Stat, Calculators, and Custom. And then your values are going to be the midpoints, and your weights are gonna be the frequency. And then all you have to do is hit compute.
Okay.
And then hopefully everybody at home came up with the mean as 43.7.
Yes.
And the part G says find the approximate standard deviation. That would be 17.8. And then part H says interpret the mean and standard deviation. And so I'm going to go back and share my paper screen so that we can all write this together. So interpreting the mean and standard deviation is in your course pack. And I keep reminding everyone because you're going to want to write this on your note sheets for the midterm so that you've got it, because on the chapter 3 review worksheets, you're definitely going to have to use the script. It's page 86 is the script. Page 86, if you want to write it there. It says we expect, and then we're going to fill it in our story. So we expect the age of drivers in fatal vehicle crashes to be, and then we're going to use the mean 43.7 years. And then it says give or take. So the give or take is our way of saying standard deviation, but we're saying it more formal. Give or take, and then standard deviation would be 17.8 years.
What is the YN?
Oh, that's an R for years.
Okay.
I'm not offended that you called me out. Too funny. Okay, so again, sharing with everybody at home, this is page 86 in your course pack. You're going to want to have these interpretations right here, the script for interpreting mean and standard deviation. You're going to want to be using that, and that's what we did here. As an example. Okay. The next page on the dot plot, I thought I'd go over this because reading a dot plot seems easy, but then it does feel kind of weird sometimes for students. So the dot plot, this is the dot plot for number of pets for households in a subdivision. So let's just look at this 8 over here. This 8 over here says that there's one household. So each of these circles are households. So there's one household that had 8 pets. There were 5 households that had no pets. Okay, so that's kind of how we read that. It says, what is the mode number of pets per household? Well, the mode is the number of pets that occurred the most, and that would definitely be 1 pet, right, that occurred the most. 1 pet. It had the most households or dots, right? These are our dots here. It says how many houses are in the subdivision. So we could add up the dots. Let's just write this, add dots. So if we add the dots, we find out, I think there's 17 of them.
Mm-hmm.
How many pets are in the subdivision? Ooh, so we have to find out how many pets are in each of these groups. So this group doesn't have any pets, so there's 0 pets for them, right? And then there's 1, 2, 3, 4, 5, 6, 7 houses that only have 1 pet. So there's a total of 7 pets there. Then these 3 homes each have 2. So there's a total of 6 pets in those homes. This home had 4 pets and this home had 8. So if we add these, we get 25 pets.
Mm-hmm.
It says, what is the mean number of pets per house in the subdivision? So we could do pets per homes and do 25 divided by 17. But that's only because we had a small data set. We could kind of just, figure these out. We kind of did them by hand. But if you're in Statcrunch, we have a data set that we can use. I'm going to share my screen with y'all. We have a data set that we can use that is the pet data. Let's find it. It's right here, 3.3 worksheet number 2, pet data. I've already put it in there for you, pets and households. So I just listed out the possible number of pets. And don't forget the number of pets that didn't have any households. I put 0 just to account for those here. And then again, let's just practice doing our weighted mean. We're going to go to stat and calculators, and we're going to go to custom. And then my values are the number of pets and my weights are the number of households. And when I hit compute, there's the average number of pets, which would be 1.47 pets. And then after a paper here. It says, what is the median number of pets? And that's where half of the pets are below and half of the pets are above. And so if I have 25 pets, that means the 12 below, the 1 in the middle, and then 12 to the right. So the 13th pet is the very median pet, right? So there's one or household.
Does median mean again?
Median is where 50% of the data below and 50% of the data is above. So 50% of the households.
Okay.
So there are, we're going to count the households. There are 17. So that's where we have to find the middle of the 17. So that would be 8 and 1, 2, 3, 4, 5, 6, 7, 8. So the 9th household is somewhere in here, and you could work backwards too, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th household is somewhere in here, right? So they had 1 pet. So the median number of pets is 1 pet.
Okay, so median isn't the one that occurs the most?
Nope, that's the mode.
That's the mode, okay.
Yeah. And then there's the median is where half is below and half is above.
Okay.
Mhm. And then F says a student claims that the mean for these data is 0 plus 1 plus 2 plus 4 plus 8 divided by 5 equals 3. Explain what the student is doing incorrectly and why it is wrong. So these are all pet values, right? But it didn't account for the fact that there are 5 households that had 0 pets and 7 households that had 1 pet. So it did not account for the weights.
Yeah, I feel like they're only looking, like they only accounted 1 house.
Right.
That, yeah.
They only accounted for 1. They did not account for all households. Yep, they only counted 1 house basically in each of those pet categories. Yep. Yes, that is true. Okay. So today I also wanted to go over into 3.4 and 3.5. And 3.4, so I would like to skip ahead to 3.4 worksheet number 2 on page 452. And we can take just a minute here, and I'm gonna pause for my folks at home to read this story. It's on, in 2017, a pollution index was calculated for a sample of cities in western and eastern cities in the US. And they collected data on air and water pollution. So read through that, and then we'll be right back to start looking at the Z-scores for Detroit, Michigan, and Salt Lake City.
So if we miss a class, we can watch this recording.
Yep. Yep, you can always, I always post them, and they're there for the whole semester, so you can watch all the recordings.
Okay.
Yep. So it says in 2017, a pollution index was calculated here. And the data they collected, so the eastern cities had a mean of 35.9 points with a standard deviation of 11.6. The western cities had a mean of 43 with a standard deviation of 11.3. Higher scores means more pollution. Yikes. So Detroit would be an eastern city, and Salt Lake City would be a western city when they refer to that.
Okay. What is like the definition of like, because I know like what the mean is, like the average. What is like the standard deviation technically?
So that's where, when you go back and watch the videos, you'll see it all in the YouTube videos. I go through everything, but the standard deviation is, on average, how are the data points varying from the mean
Okay.
on average?
So,
And so, go ahead.
so standard deviation is focusing on the mean, where the mean is like the overall.
The mean is the average for all the data sets, and the standard deviation is like how, basically it's a measure of how spread out the data is. So the bigger the standard deviation, the further away all the data is from the mean. The smaller standard deviation means that all the data points are really actually centered about the mean.
Okay.
Yep, and the YouTube videos will help with that too.
Perfect.
So they want us to calculate, it says Detroit, Michigan has a pollution index of 56.2, calculate its Z-score. So the Z-score is the average number of standard deviations that an observation is from the mean. And this is in 3.4. So its Z-score is equal to the observation, so 56.2, subtracting the mean from the group, which is 35.9, dividing by the standard deviation of that group, which would be 11.6. And so that, if you're going to use Desmos, just make sure that this all goes in the top, or you can use any calculator that you choose. And this comes out to be 1.75. And then Salt Lake City had an index of 61.4, and they want us to find its Z-score. And it's a western city, so the average of the western cities was 43, higher than the eastern, and a standard deviation of 11.3. And that comes out to be 1.63. So it says, which city has more pollution in absolute terms? So that's just comparing pollution rating to index score to index score. So it looks like Salt Lake City actually had its score was actually higher, right? Its actual score.
Because it says higher scores means more pollution, right?
Yep. And then it says whose city has more pollution in relative terms. So in relative terms means apples to apples. So Detroit should be compared to other Detroit eastern cities, right? And Salt Lake City should be compared to other western cities. And so that's why we look at the Z-score. And so it looks like Detroit on average is higher than the other eastern cities by 1.75 standard deviations, whereas Salt Lake City is only higher than the average western cities by 1.6. So Detroit is relatively further away from the average than Salt Lake City.
Okay.
Yeah. So E says San Antonio, Texas in the west had a z-score of 0. Explain what that means for San Antonio and its pollution index score. So in the YouTube videos, we talked about how you can have a z-score of 0. Remember that z-score by formula is the observation subtracting the mean divided by the standard deviation. So the only way that you could get a 0 z-score is if there was 0 difference in the numerator, right? Which means that San Antonio must be at the average. San Antonio must have an index of the average Western, which would be 43.
So what does the z-score mean?
The z-score is the average number of standard deviations that a particular observation is away from the mean of the group.
Okay.
Yep, so Detroit, their actual city score on the pollution was 56.2, but the average for all the eastern cities was only 35.9. So they're definitely higher, right, on pollution than the average eastern group.
Mhm.
And then the group of the eastern cities is 11.6. So its z-score is, they're not quite 2 standard deviations above the mean.
Okay.
F says Boston, Massachusetts had a z-score of negative 0.767. Calculate Boston's pollution index score. So the z-score is negative 7.767. So we don't know Boston's actual score, but it's an Eastern average. So we're using the 35.9 and the 11.6. So we get to use a little bit of algebra today. We don't get to use algebra very often, but we're going to multiply both sides by 11.6 to try to solve for x here.
Ooh.
So we only have to do this very few times this semester. So when we multiply the left side by 11.6 times a negative 0.767, we get a negative 8.897 equals x minus 35.9. And so to solve for x, we need to add, yeah, 35.9. See, this is like a little bit of algebra we have to do. So when we add 35.9 to both sides, we get almost 27 even, actually. So Boston has a really low pollution, actually 27 is really low.
Compared to, yeah.
Compared to the average.
Mhm.
And we could tell that they were below the average because their z-score was below average, right? But not that below, not even a whole standard deviation below. So they're not unusually below or anything.
Mhm. Yeah, the Detroit one, I'm not shocked.
No, I'm not shocked either.
I haven't been to Salt Lake City, so I can't say.
I haven't either.
Utah, like, I could forget, like, there's a state called Utah, you know?
I heard there's so many cool things in Utah. I need to go.
Mhm.
There's like snow and you can go skiing, and then there's deserts in Utah too. So I mean, they've just got everything. Okay, so the last big problem I'm going to go through today. I'm also going to put a link up of the live session from my winter 7-week course. So if anybody wants to see other extra worksheets worked out, you'll get to see those as well. But this last problem I'm going to do today is from 3.4 worksheet number 2, page 2. And it's problem number 2. And you can find the data set in Statcrunch.
Okay.
Yep, so if you want to find it in Statcrunch, let's just go there. This is the number of hazardous waste sites for each of the 50 states in 2016. So there was one state that had 0 hazardous waste sites, and there was a state that had 113 hazardous waste sites. So I'm going to share my screen and go to that data. And it's worksheet 3.4, worksheet number 2. 3.4, worksheet number two. There it is. And yep, I've already listed them all out for you all. So they're all listed. There should be 50 of them. Yep. And it's asking us to find the mean, standard deviation, Q1, Q2, Q3, IQR, whoop, all this stuff that we learned in chapter 3. So where we find our summary statistics is by going to stat and summary statistics. And we're going to go by columns, and we only have one column in this data set. So we're going to choose that one column. And because this is population data, right? Because population means we have all of the states, we're not just taking a sample, then we also have to include our unadjusted standard deviation. So that's over here in the gray. So to, oopsie, we're going to include everything. So go down, and I'm going to go down the bottom underneath unadjusted standard deviation. I'm going to hit shift, and I'm going to click on unadjusted standard deviation. So it's going to give me everything over there, all the way through unadjusted standard deviation. Because remember, in chapter 3, YouTube videos tells us that the unadjusted standard deviation is when you have population data. Otherwise, you can use the standard deviation that comes out of Statcrunch regular, because that's for a sample. So this is everything that came out. You're going to need to know how to do this for the chapter 3 project, finding summary statistics. So
I'm having a hard time, like, which ones did we select?
let me go back to that. So we're going to go to stat, summary stats, columns, and then we're going to click on, in the gray box, we're going to click on N, and then I'm going to scroll down. You see, you can grab the little box and scroll down.
Yes.
I went to the one that says unadjusted standard deviation. And if you hit your shift key and click on that, it should highlight everything in between there. Want me to help you again? It's kind of,
I think I just. Okay, got it.
yep. And then compute.
Okay, perfect.
Yep. So let's just go through everything that's on here. So N is 50. That's the number in our, it's not a sample, but our compilation, right? All 50 states. They gave us the mean. So we're going to write, I'll share my screen so everybody can see what I'm writing, but we're going to put the mean in our box there on our paper. So 26.06. The standard deviation, don't use the first one they give you. You have to go all the way over here to the unadjusted, because we want the population standard deviation. So 25.87, 25.872, 3 decimal places. They gave us Q1. Remember that Q1 is the marking of 25% of our data is below Q1, just like a quarter in your money is 25. Q1 is 25%, so Q1 is 11. Q2 on our paper, we don't see a Q2 on our printout, and that's because Q2 is always the median. So make sure you jot that on your paper. Q2 is the median, that's 15. Q3 is 37, and just like in our money, 3/4 is 75 cents. And that also stands for 75% of our data had less than 37 hazardous waste sites. And then we're done calculating from there. Oh, they gave us the IQR, but in our course spec, we learned how to calculate the IQR. It's Q3 minus Q1. So notice that would be 37 minus 11, and they gave that to us, which is 26. That's really nice that they gave that to us. TI-84 does not give us that, but they did. They're super nice.
Okay.
Okay, so let's go back to our paper so we can all make sure we have everything filled out the same. Now, letter B says, are the values found above parameters or statistics? And they are parameters because remember in lesson 1.1 on the YouTube videos in our course back, we said that parameters go with population data and statistics go with sample data. And so these are parameters because we have population data. So remember on any of your midterm or the worksheets that get turned in, whenever you see this word explain, I'm expecting you to give me some kind of a reasoning answer. So because we have population data is enough to say that here. Okay. Find the lower and upper fences. So lower and upper fences in our course pack. So let's remind ourselves where that is in the course pack. That is in 3.5, 3.4, 3.5 on page 103. So, I want to bring this up, why we're even finding the upper and lower fence, because we said when we have symmetric data that we're going to use the mean as our measure of center, and we're going to use the standard deviation as the measure of spread. Okay, that's on page 68. And I'm going to go back there for a minute because I want to make sure everybody's remembering that. I mean, that's on page 78. Okay, but on page 106 in our course pack, I don't have it written here, but on page 106, when our data is skewed, so skewed left or skewed right here, our best measure of spread is going to be the IQR. Okay, so not the standard deviation. So when it's symmetric here, when it's symmetric, we're going to use the mean as our center and the standard deviation as our spread. But when it's skewed left or skewed right, we're going to use the median as our best measure of center and our IQR is the best measure of spread. And so that kind of takes us to the idea of, well, if we're using, if our data is skewed, and we said, well, how do we tell if it's skewed again? Remember, we talked in earlier in chapter 3 that our mean compared to our median, that's Q2. So the mean always on the left, the median always on the right. We're going to do an inequality. The mean is definitely much bigger than our median, isn't it? 26.06 compared to 15. So we're going to write the inequality. This is bigger than this. And so whichever way our arrow is pointing to the right, that tells us it's skewed right, which they're not asking us that. But that leads me to the next statement of when we have skewed data, how do we tell if we have an outlier? So earlier in chapter 3, we said we have an outlier if our data is further than 2 standard deviations away from the mean. Well, that only works, and we did this in chapter 3.3, that only works if our data is bell-shaped and symmetric. So remember the curve that we made in 3.3? Well, this data is not symmetric. We just said it's skewed right. So if it's skewed right, we have to have another way to decide if our data is considered an outlier. And that's by using these things called the upper and lower fences. And the formula for the upper and lower fences is on page 103. You can use that as a reference and go back there and find that in your course pack. And our lower fence is calculated by taking Q1 minus 1.5 times the IQR. So let's just write that. The lower and upper, we're going to find those. Okay. So the lower is found by taking Q1 minus 1.5 times the IQR. So Q1 is 11 minus 1.5 and IQR is 26. Get our calculator here. And 11 minus 1.5 times 26. And that's a negative 28. Okay, so our upper fence is a similar calculation, but it's not just symmetric. We start with Q3 instead of Q1. So the upper fence is Q3 and we add 1.5 times the IQR instead of subtract. So Q3 is 37 plus 1.5 times 26. Get out my handy dandy calculator. And that is 76. So it says list any outliers. So an outlier in this case would be any data points that are less than a negative number of way sites. Well, we can't even have that, can we? So if I ask you to calculate them and they come out to be negative, that's fine. You just probably won't have it in this case, right? We can't have data values that are negative. But do we have any states that had more than 76 way sites? Oh yeah, anything bigger than here, right?
Mhm.
There is 1, 2, 3, 4. So that would, I'm going to put them in brackets. Whenever you use brackets, that's to make a list of something. So I'm listing 85, 95, 97, and 113. Okay. Michigan has 65 hazardous waste sites. Find Michigan Z-score. So this lets us practice Z-score again. So the Z-score for Michigan is Michigan's observation of 65, subtracting the average, which is 26.06, divided by the standard deviation of 25.872. And again, make sure that you either put these in parentheses or complete the numerator first. Otherwise, you're going to get a weird Z-score. And Michigan's is 1.51. It is not unusual. They didn't ask us that, but it would be unusual if they were further than 2 standard deviations. Remember, we talked about that earlier in chapter 3 as well. And the last question says, hazardous waste sites per state is what type of variable? Is it qualitative, quantitative discrete, or quantitative continuous? And it is quantitative discrete because we can't have half of a waste site.
Wait, can you explain that one again?
Yep, that's 1.1. So when you watch that video, we'll talk about that. A discrete variable, quantitative, it's numerical, but it's discrete because you can't have half of it. You can't have half of a person or half of a pen or half of a house or half of an animal.
Okay.
Continuous is a variable that is measurable. So like weight or time or length or liquid or gas prices, anything that's averaged is always continuous as well.
Okay.
Yeah, and we'll, again, once you go back and do those with your course pack now, you'll be all caught up on that.
Okay.
So that is all I have for today. If you want more help with 3.4 and 3.5, you can check out the live videos that I listed from my winter, and I will note those in JetNet so that you've got those to help guide you as well.